My name is Josh Stroschein, a malware analyst security researcher. I work for VDA Labs doing malware and AppSec as well as doing trainings. So that's one of the other reasons that brought me here. Also a course author for Pluralsight. I have my first course coming live here anytime, so excited about that. And then I teach at Dakota State University, which is in the middle of the United States, in the middle of probably nowhere to many people. Before we get into the actual talk, just a couple of things I wanted to caveat. I'm not discussing any CVEs of recent fame. There have been a couple that have achieved some notoriety. I'm also not announcing anything new or undiscovered. This is all really just a survey of techniques that I have seen used throughout the last year or so as I've analyzed malicious documents, and ones that are just taking advantage of really the core feature set that's available in an Office document. Probably the biggest thing that we'll notice, aside from the technical techniques, but the exploit itself, is probably the human being or the user. So social engineering is definitely one of the more effective things that we'll see throughout some of these documents. Of course, training is hard, especially with non-technical users, to get them to understand the ramifications and what can happen when they open a document. Just closing it as fast as they can typically isn't enough, because at that point it's really too late. Everybody's busy. They don't always take time to stop and think. Even very technical, security-savvy users can succumb to a very enticing document. As far as Office goes, it is very powerful. We will take a look at some of the Visual Basic, or VBA, is what the language that you write your macro code in. And it turns out it is very powerful. I'm not a macro developer. I don't spend a lot of time in them, except if it's a malicious document. And so I was really surprised at how much can actually get done there. Macros work. They're totally legitimate use. There is no patch for a feature because they are intended to be a core part of the Office suite. So day in and day out, people are using them for all sorts of very legitimate, productive business needs. Of course, if we send out a spam campaign, all we have to do, we could send out 10,000 emails as a malicious actor and attacker, and all we need to do is get one user. And so that's really the goal here, is how can we use an Office document as a delivery technique in order to get that initial foothold, that beachhead, into an organization, to get that one user to execute code. I'd like to start with a basic concept of operations. All right, we have our Office documents, a doc, a spreadsheet, a PowerPoint, really anything in the suite that allows you to enable macros. This brings us to the next stage, which is the macro execution. So the document itself, default settings would require a user to enable content, and the verbiage just sometimes changes based off of the actual version of Office. This doesn't mean, or I'm not trying to imply, that only macro-enabled documents are malicious. There are some techniques, as I alluded to earlier, with some of the more recent CVEs around the Office suite, where attackers are trying to find ways to get code to execute, scripts or otherwise, without using macros, although they still require some degree of user interaction. After the macros, we usually have a varying number of stages, which brings with it PowerShell, JavaScript, shell code, executables, DLLs, and this can vary based off of the authors, the campaigns, what they're trying to deliver. But oftentimes, at least from my experience, we're not getting the final payload or the final malware here at this stage. We eventually do get there. The malware is finally dropped, so these stages could come from within the document itself. These could require a round or two or three of going out to a command and control network to get that additional content, and then we're dealing with post-infection, which is not something we're discussing today. So macros can contain embedded code, VBA, Visual Basic for applications. Again, well supported, it's well documented by Microsoft. You can find pretty much everything on MSDN, the Microsoft Developer Network. Something that surprised me the first time I saw it is that you can also access the Windows API through your VBA. A colleague put it in perspective the other day, or maybe it was a podcast, I don't remember where I heard this, but Windows was inherently written for developers. And so I always keep that in mind, that it was really developed to be a relatively powerful operating system. So this begs the question, if we're interested in inspecting macros, how are we going to be able to do that? There's two techniques that I typically use. The first is OLE dump, and I figured this was as close as I was going to get to being able to personally thank Mr. Stevens for the work he's done with the OLE dump scripts, knowing that he's here. So we'll take a look at those. The second is the Office IDE, the Integrated Development Environments. Another thing I was relatively surprised of when I found out is how extensive this IDE is within the Office suite, and then of course my ability, or your ability, to use it during analysis, not just for writing macros. So let's start with OLE dump. The most simplest use of that script, again, it's a Python script, is to run OLE dump on your Office document. And what this will produce is more or less a table of contents. We have basic information, an index or a stream on the left. Those are numbered sequentially starting at 1. Then we have indications of what streams contain macros, upper and lowercase m's. The uppercase m's contain the actual code, and the m's just define a module. And you'll see some correlations here a little bit later on. Then you have the size, and finally you have the names. And I imagine that everyone in here has used Cowkeeper as a name for a class or a module in their own development at least once in their career. We get down to some additional content here that I've highlighted, and these actually took me a little while to puzzle out. We have, the only thing I could see there at the end was F and O, and these would consistently show up in certain documents. What it turns out they are user forms, and what those user forms then are used for is to embed or hide additional content. So maybe an executable, maybe some shell code that the Office doc, the macros, will eventually use. Here again, example of very simple use of OLE dump. We have the tool, the script itself. We have our document. In this case, it's I believe the SHA-2 of that document, so a rather lengthy name. In order to begin inspecting macros, we have to give it a stream. So you have the -s and then the stream number, the index, and then finally -v. Those streams are compressed within the document. So if you forget to decompress those, you're not going to be able to see that code in plain ASCII. From here, you might just redirect it to a file. That's oftentimes what I do. And now you're able to look at the code. So opening it up in your favorite editor, and away you can go. Another option is to enable the developer tools in Office. And you go into the options, you'll be able to add that to your upper ribbon, and then a new tab will show up. From this tab, once you've opened this malicious document, then you can select Visual Basic, and that will open up basically the IDE. You have now the project view of this same malicious doc. This is what it looks like. Very similar to that table of contents view that we saw with OLE dump. Name of the project, name of the streams or the modules, that's where the code is, the macro code is. And then in this case, you can see a user form. So this is a legitimate malicious document. And as I said, with the OLE dump, you can see that there was a user form, the F and the O, but this one allows you to actually open that form up and see what's on there. Now, I don't necessarily always care about doing that. I'm more interested in trying to identify how that form is being used, and if it contains some encrypted or obfuscated something, a script, some shellcode, an executable, at what point in the macros does that get pulled out and deobfuscated and decrypted? Another thing that the IDE will enable you to do is to allow you to debug. And this can be very helpful, especially when you deal with obfuscation, which I'm pretty sure every malware author has to go through the basic obfuscation training so that they can use the same techniques in all their documents. Just like any IDE, once you have your script or your code loaded, then you can click in the margins. That will indicate the breakpoint is set with that red dot and then highlighting that rest of that line in red. And from there, you just click play or execute. Of course, you're dealing with a malicious document, so you have to make sure you're in an appropriate environment because you're about to execute the code. One other small caveat with this is that you can't begin debugging until you've already enabled content. So I know some workarounds and tricks to do that, but the most straightforward route is you let those macros execute and then you can start debugging them. So it's kind of a disconnected process. Once you begin debugging, assuming that your breakpoint is hit, you're now free to do all the normal debug things. Step in, step over, step out, as well as to pause or stop execution. This is great. I'm inherently lazy, and I don't want to have to spend a lot of time tracing through heavily obfuscated code. I've done enough of it. It's annoying and time-consuming and can become very tedious. So as an example, if I want to see the argument that's going to be passed to this exec query function, instead of trying to trace through all these poorly named variables, instead what I'll do is just set a breakpoint, run through the macros, add watches onto those 3 variables, and then see the results down below. And now I can clearly see that it's trying to select the disks on whatever system it's running on. It happens that you'll encounter passwords, and I suppose that these may add some sense of legitimacy based off of the campaign to maybe that end user, the victim that they're targeting. But it also can complicate analysis, and that if you don't have the password, you're not going to be able to pull those macros out of this document. So you'll have to resort to analyzing its behavior without seeing the macros. Again, this talk assumes that you want to get in and see the macros. I'm not proposing that this is the most effective way. Sometimes the easiest thing to do is put it in a sandbox, let it run, and then just collect the artifacts. But with that password, some older versions of Office, you could actually find, open up in a hex editor, find this certain section and basically disable it. I don't remember all of the steps offhand, but with newer versions, I've had more trouble with that. The other thing that this can complicate, of course, is if you throw this in a sandbox and you are not able to then, it's an automated sandbox, you're not able to feed the password. So the doc will open, it'll stay, the password prompt will be there, waiting for that input, and it'll never come, you'll never get any results, and if you don't catch that, you might not think it's malicious. As we started off the talk, social engineering abounds. It seems to me the most prevalent method for social engineering is to use a kind of a message such as this. That is that this version that you've just opened this Office document with is incompatible with the version it was created. So you need to enable content in order to see what's really here. The goal, of course, is to enable macros. Here's an example, relatively poorly worded, but the message that contained as an attachment the document as well as the password. So this one, again, relatively simple password, but they're trying to use that as a way to add a little bit more legitimacy to the message that they sent to that potential victim. This has been one of my more favorite as far as messages goes, or social engineering. This one was a relatively well-formatted, well-structured HTML email that had all of the right logos, very nicely done. The attachment was the Office doc. I guess you could say one of the first flaws is that this is supposedly tracking information. So UPS has missed you at your door, and they're now sending this tracking information to you via an Office document. Once you open that document, you'll see that it has been protected or encrypted for your benefit. And in order to see this, you have to enable content. So now we can get to the use of forms. And this is a slightly different document that we were looking at earlier. You can, again, notice in the streams or the index 14 and 15 that we have a user form, F and 0. If you look at the third column for stream 15, it has a relatively large size, which is kind of odd. Having looked at enough of these documents, that stood out. If you open this up in the IDE, then you'll be able to look at that user form. And oftentimes I find that those user forms, the objects that they place on the user forms to embed that content are pushed way off screen. So this one, though, you could expand a little bit and you might find your content. Here you might be able to recognize what appears to be a PE file or a DLL, a PE file nonetheless with the magic numbers 4D5A, although it is still slightly obfuscated in that the byte values that you see right now, we would normally see those as binary values. And so they just took that binary value of the original PE and then converted it to ASCII. So the job of the macros, that I guess allowed them to embed it into this content and also avoid scanners. So the job of the macros is to then reverse that, to take each one of these ASCII characters, write it back as its original binary value, and then it can execute the file. Another area that stumped me up for a little while was trying to identify where these form objects are actually used. Once you get into the IDE, you can identify those. So you could select this text box, and then in the properties dialogues, you'll see the name, transducer. So now in the macros, you'll see the name of this form, and then you'll see dot, and then that object, so the form.transducer. But again, I didn't find any reference to that until I was able to start to piece together that the forms were being used. So then once you identify those form elements, again, you can trace and track the code that is now hidden or embedded inside of them. You can also extract that content with OLE dump. So using the same syntax that we saw before, you just don't decompress. So OLE dump, the stream number minus the -v, and then the name of the document. And here you'll have the raw content. So if you knew that that wasn't in an obfuscated form, or you knew how to deobfuscate that because you were interested in looking at whatever that next round of code was, you could extract that with OLE dump and then start working with it. In this case, I had a little Python script so that would go through and do that byte back to binary conversion. So I was able to extract this content with OLE dump, run that Python script on it, have the original executable and analyze it. I did that more of an exercise than anything because, again, you could also have just ran that in a sandbox environment. It would drop the exe for you, and then you could grab it and analyze it from there. Obfuscation, lots of obfuscation. Not necessarily the most effective, but effective enough to slow down if you're trying to perform any sort of manual or visual analysis of this code. As with most or a lot of interpreted languages, what you're trying to hide, you have only a fairly limited set of options, because at the end of the day, if you're trying to hide this code, eventually it has to be valid syntax. So you'll see a lot of strange naming, whether that's through the functions or the variables, which just really makes it harder to trace those particular objects, to trace the functionality through the scripts. You'll see a lot of string concatenation and string obfuscation, and manipulation. So later on, concatenation. So break up, let's say you want to execute a PowerShell script. You break up all the components throughout different variables, maybe throughout different modules. Then when you're ready to execute it, you concatenate those all back together. So you find that point, and hopefully then you've been able to defeat that obfuscation. So reversing strings, doing substring stuff, that's all a big part of it. You may find a lot of nonsensical, or at least nonsensical in the terms of the overall objectives for the behavior of the code, instructions. So here we have just some arithmetic, rather verbose arithmetic as well, but none of these variables are used throughout the rest of the script. So they're just there as filler to make you waste your time having to inspect those and see if there's any sort of a relevance there. You'll get junk control structures, switches and ifs and else ifs, as well as loops, a lot of loops, which aren't doing anything. And this is another example. So you might look at this chunk of code, and the only thing that is even relevant for the functionality is this last line here. And you can see this is part of the from Win32 that we looked at earlier. As I mentioned, we have also the Windows API. So this document came with a bunch of aliases, so you can see the DLLs, the modules, the libraries that they're loading from, as well as the specific APIs. In addition, they decided to inject some comments that were lyrics from all sorts of different music, I guess just to provide some entertainment for us. This is the library, user 32, kernel 32, and then those are the APIs. You'll also notice that they are creating these aliases. So when we want to identify the use of any particular API that's being imported, then we have to find it by the alias. So again, just another level of indirection to make it a little bit harder to trace this code. Here you can see that enum date formats W is alias with cabriolet, and it's used later on in those macros. So then you can identify that usage. Let's talk about that one, because that technique, and specifically that API, was used in this document in order to stage and eventually execute some shell code. So here's the MD5 if you wanted to grab it and follow along at any point in the future. What I decided to do was, there's two things with those APIs. As there can be a long list of imports. Not all of them have to be used, and even the ones that are used, that doesn't necessarily guarantee that they're relevant or important. This one ended up being important, and the reason that it was important is because this is what allowed for the execution of the shell code. The first argument, you can see there, APRUM, that argument for enum date formats is an application-defined callback function. So all that function is doing is expecting an address where it should go and execute code. So that's why this worked in this document in order to execute the shell code. What we haven't talked about is how did that get there in the first place. And so in that list of imports, there was an import for virtual alloc. So that was used to allocate the memory, and then a memmove API, and I forget which one it was, RTL move memory or something. So it already allocated RWX memory. It's already staged, deobfuscated, and then staged that shell code in memory, and now it's ready for execution. If you're interested in extracting, as I was, that shell code from memory, what I decided to do was to set a breakpoint in the Office IDE at this function call. This allowed me to determine the value of that first variable, which will be the address in memory that shell code is at. Not only is it the address in memory, so we'll find the base of this allocation 70D0000, but it's also the offset. So it's beginning execution at an offset from that base at E5D. That's important because if I want to take that shellcode out of memory and disassemble it, it's usually very helpful to know the entry point so that I can tell my disassembly tool to start in the right location and get accurate disassembly results. Using a tool like Process Hacker, there's the allocation, you can see the base, and of course our WX as we might expect, so execute permissions. And if you look at the actual content in memory, I've highlighted the first byte, that's 55, so opcode 55, which is a push EBP, which is normally one of your first instructions in a regular function prologue. So that gave me just good confirmation that I was on the right track and that this is fact is shellcode and I can go ahead and extract it and analyze it. There's a demo, that document, if you wanted, the slides are available, I believe, on the Hack in the Box website. The next document, I used a PowerShell. This one was exciting because it was authored by PowerShell itself, so I was really interested to see what PowerShell had to do with macros. You'll notice that it's going to hide itself, and then it uses that encode parameter. So the contents of the script are actually encoded, base 64 encoded. So again, first thing I did in order to see that was to base 64 decode. Now, I don't know if this was a flaw in my approach or if it was an intentionally injected, but every time I decoded that, I got all these annoying 3-4 bytes. So between every character was this binary 3-4. So I had to first open this up in a hex editor and pull those out in order to get ASCII that I could begin to analyze. This is the macros, really just bootstrapping the ability to execute this PowerShell and creating a wscript.shell object and then running that script after it's grabbed it from the author. You'll also notice here that there's an error handler, and if this were to fail, initially targeting a Windows user, then it'll try the Mac shell. Probably it doesn't leave a lot to imagine what Mac shell is going to do, as well as the Win shell as well. This is one time they're actually very accurately descriptive. This is the content of that first stage of PowerShell, and while this is a fairly busy slide, the gist of it is that this is all one big string. And what this document or PowerShell script is doing is it's going to base 64 that string and then execute using IEX. So there's another stage here. This is the second stage. Again, it looks a little busy, but this byte array here is more shell code. And what this PowerShell script is going to do is just simply call virtualalloc, copy that shellcode into memory, and then create thread. I think this looks like one of the maldoc frameworks out there. I think this is code that looks very similar to that, although I haven't looked at it. What does that shellcode do? I didn't actually analyze that. It tried to make a request to that domain to get that resource. It wasn't available at the time that I grabbed this doc, so I wasn't able to go any further anyway. Not every document, as I mentioned, has to contain macros. This document here did not contain macros, but when you open it up, you find what appears to be 3 embedded Office documents that contain all of these invoices that apparently you are now late on. If you extract those, though, they're not invoices, of course, they're not documents, they're VB scripts. And so double-clicking those will begin execution of those VB scripts. Looking at those content of those scripts, they were all identical, so you can generate a hash on those and you'll see they're all identical, and of course they're all obfuscated. What those scripts did, dropped 2 files. One of them was an executable and it was recognized as a Trojan. So another kind of oddball technique that I've run across, and I'm sure many others have as well, you can see the detection ratio at the time that I put the slide together on virus total. This one used certutil. So it dropped one resource when those macros began executing. That was this PFX file. And what it did with that file was to use certutil to code. So that is another base 64 encoded file. It then writes that out as an executable. And because it invoked all of this through a command, command exe, then it goes ahead and executes that once it's done. All right. Finally get back to our Mac shell. So if you think back just a couple minutes ago when we talked about the PowerShell that document initially dropped, what this is doing then, this is the other branch. So an exception occurs because it can't execute those Windows commands, those objects on your non-Windows host, then it'll go and try to call this. This has been snipped just for brevity, so it would fit in the slide. Again, the kind of the gist of it is that it creates this socket. It had this hard-coded IP that it was going to try to create a connection to at that particular port number. It was then grabbing standard out, standard in, standard error, and allowing those to then, or redirecting those to the remote shell, and then calling that shell. The last step was to use MaxScript, which is on MSDN, deprecated, but apparently still supported, and it would use that in order to invoke basically this Python. So not nearly as maybe sophisticated as a lot of those other Office Windows-based techniques that we were looking at, but I suppose if they got a reverse shell, then it was worth the effort. I talked fast because I thought I'd run out of time, so I guess I'm helping the curve and getting you guys back on schedule. Great. All right, well, thank you everyone for your time. I appreciated having 25 minutes with you.